Alright, today we're going to talk about work. The objective for this is the students will be able to identify the factors affecting work done by constant forces. So go ahead and get your notes out and something to write with, and let's get started. So there's the equation. And that's on the AP equation sheet as well. So let's talk about what all these symbols mean. W stands for work, which is measured in joules, and the symbol for joules is J. Force is F, measured in newtons, like it has been so far all the time. D means displacement, measured in meters. And the cosine theta refers to the angle between the directions of the force and the displacement. Those parallel lines after the F mean the force is parallel to the displacement, meaning the angle between the force and displacement would be 0, hence having no angle. And then cosine of 0 would be 1, so it's like the cosine isn't even there. That only works when you're pulling perfectly parallel. Joules, or J, is the unit for work and energy, and 1 joule is the same thing as 1 Newton meter, or 1 kilogram meter squared per second squared. So we'll use J. It's named in honor of James Prescott Joule, who lived in the 1800s and did a bunch of work on energy. So here's a picture showing if you pull something at an angle, like if you're pulling this box, but you're leaning over to grab it, so you're not actually pulling it at a complete parallel to the floor. You're pulling up at some angle theta. So really the force that's moving the box is only the horizontal component of that force. So that horizontal component of the force, the F cos theta, times the displacement over which the force is acting gives you how much work is done. So the force you're pulling with isn't necessarily the force that goes in this equation, because you have to do the cosine part. Time for a challenge question. If someone runs around the track one whole time, which is 400 meters, with an average force of 10 newtons from your body propelling you forward, how much work would be done? So some people would take 400 times 10. 400 meters, that's the displacement, times 10 newtons, that's the force, and get 4,000 joules. And that would be wrong. Because really, if you run around the track one whole time, your displacement is 0, meaning no work was done. In other words, any time you end where you start, you did no work. In physics, anyway. So here's some other examples when there's no work done. In the picture on the left, if you push on something but it doesn't actually move, then there's no displacement, so there was no actual work done. It didn't move. There was no change in position. This picture on the right shows a guy holding a box and carrying it horizontally. He's moving at constant velocity, so his net force is 0. And also the displacement is left and right, where the force on the box is up and down, counteracting gravity. So really, if the force isn't even in the same direction as the displacement, then no work is done. And additionally, the net force is 0 if he's moving at constant velocity, so the force would be 0 anyway. Which means the work done is 0, no matter how far he goes. So make sure to bring your notes with you next time. There'll be an open note quiz as always. And make sure you log into Edmodo and take the online homework quiz. And thank you.